Hello, Williams class. For your arithmetic today, the questions are as follows. 22 times 100. What is a quarter of 40? What is 356 as a Roman numeral? What number is next in the sequence? 42, 50, 58, 66. 2 times 6 equals 45 divided by 5. What is 15 meters in centimeters? 3,461 plus 3,401. 5,698 take away 3,454. 56 divided by 7. Here are your answers. 22 times 100 equals 2,200. What is a quarter of 40? 10. What is 356 as a Roman numeral? CCCLVI. What number is next in the sequence? 42, 50, 58, 66, 74. 2 times 6 equals 12. 45 divided by 5 equals 9. What is 15 meters in centimeters? 1,500 centimeters. 3,461 plus 3,401 equals 6,862. 5,698 take away 3,454 equals 2,244. 56 divided by 7 equals 8. Your learning objective for today's maths lesson is, can I understand what equivalent fractions are? So by the end of this lesson, you will be able to verbally, that means out loud using your voice, explain what an equivalent fraction is. You will be able to define what a fraction is, and you will be able to use concrete materials to show equivalent fractions. A quick challenge for you. I would like for you to grab 2 strips of equally sized paper. Number 1, you're going to fold one strip into quarters and the other into eighths. So you fold one strip of paper 4 times and you fold the other one 8 times in half. Number 2, place the quarters on top of the eighths and lift up 1 quarter. Number 3, how many eighths are equivalent to 1 quarter? And then how many equivalent fractions can you find apart from the ones that we have just seen in this quick challenge? Try this using your whiteboards. Using the squared side, investigate equivalent fractions using equal parts. Number 1, start by drawing a bar that is 8 squares long, like this here. And then number 2, underneath, compare the same length bar split into 4 equal parts. What do you notice? So you have one bar that's split into 8. You have another bar split into 8, but you're going to also then divide it, as you can see on the board. You're going to divide it so that each part has 2 inside of it. What do you notice? You'll notice that, let's have a go at creating fractions here. So how many parts is this out of? 8, right? Because there are 8 parts that the bar is split into. Here, if you just take the red lines as the parts that are divided rather than the lines in between, how many parts is that bar divided into? You've got 1 part here, 1 part here, 1 part here, and 1 part here. So that means that bar would have a denominator of 4 because it is split into 4 equal parts. So that means then that 3 quarters, which is this much, because I've now shaded in 3 out of the 4 parts, 3/4 is equal to 6/8. So let's shade in 6 squares of this 8. 1, 2, 3, 4, 5, and 6. Can you see them, boys and girls? How? We've got 2 different fractions there. I've shaded in 6 out of 8 possible parts, and here I've shaded in 3 out of 4 possible parts. But look, they are exactly the same size, which tells us that they are equivalent fractions. Over here, how many fractions equivalent to 1/2 can you see on the fraction wall? I'd like for you to give it a go, and then I'll tell you the ones that I can see. So 1/2 is over here, just to bring your attention to it. What fractions are the same size? I'm going to give you one as an example. What I'm going to do is I'm going to draw a line to see where that half finishes. And I'm going to see if there's another line that comes my way just there. Okay, so I've got another line. That tells me that I found a bar that is the same size as the half, and that means they're equivalent fractions. So how much is that? A quarter. Oh, and another quarter. So what's a quarter plus a quarter? That would be 1 plus 1, keep the denominator the same, 2 quarters. So 2 quarters is the same as a half. What other ones can we see? I'm going to keep traveling down, down, down. Oh, I've bumped into another line. So now what will my equivalent fraction be? I've got 1/6 here, another 6th, and another 6th. So that means altogether I've got 3/6. So 3/6 is also equal to a half because they're the same size. What other ones can you see? Let's keep traveling down. So I was there. Oh, we've got another line. So now what is this fraction? 1/8, 2/8, 3/8, 4/8. So 4/8 is the same as a half because again, 4/8 here is the exact same size as a half here. Can you see any more? I can see 2 more. I can see that there's a line here. So what's our fraction there? 1/10, 2/10, 3/10, 4/10, 5/10. So 5/10 is equal to a half. And then lastly, let's keep going. So traveling down, down, down until you come across a line. I've come across a line there. So what's that fraction? We've got 1/12, 2/12, 3/12, 4/12, 5/12, and 6/12. So 6/12 is equal to a half. Just to remind you, they're equal because they're equal in size. They're the exact same size as one another. So those are all the fractions that are equal to a half. You've got 2/4, 3/6, 4/8, 5/10, and 6/12. So let's just double check that we have gotten that correct. The ones that are mentioned, a half, we got as our starting fraction. We mentioned 2 quarters, we mentioned 3/6, we mentioned 4/8, and 5/10, and also 6/12. I would like for you to look at the equivalent fractions that you have found. So that means that the equivalent fractions that we've just found here, they're written nice and neatly for you here if you'd like to have a look. And what relationships can you see between the numerators and the denominators? Are there any patterns? Can a fraction have more than one equivalent fraction? So let's have a look then at 2 equivalent fractions, okay? I'm going to pick a half and I'm going to pick 6/12. So the biggest one, the biggest fraction that we have and the smallest one. Now let's look at the numerators, okay? Here, the numerator for this fraction is 1. The numerator for this fraction is 6. How do I get from 1 to 6? What do I do to 1 to get to 6? I multiply by 6. So that means that if I multiply the numerator by 6, I have to also then multiply the denominator by 6. Let's test it. What's 2 times 6? It's 12. So it works. What you do to the bottom, you do to the top. Whatever you do to the top, you do to the bottom. Let's have a go at another fraction, just to show you the relationship between numerators and denominators. Let's take not half and 6/12. So let's now look at 3/6 and 6/12. Okay? So how do we get from 6 to 12? What number do I multiply by 6 to get to 12? 2. So let's see if the same works here. What's 3 times 2? It should be 6. So that just tells you then, whatever you do to the top and whatever you do to the bottom, you have to make sure you do it to the other part of the fraction as well. Now, here is your independent task. You're going to use this fraction wall to complete the equivalent fractions. So for example, if we do the first one together, a half is equal to what? So a half is here, okay? What is a half equal to? We already know that the denominator is going to be 4. So you have to look at the part of the fraction wall that has a denominator of 4, which is the middle bar here. So how many parts of the quarter do you need to make a half? You need 1 part, 2 parts, just like that. So have a go at answering the rest of those questions and then we'll go through the answers together. Okay, let's look at B. So B says a half is equal to how many eighths? So a half is here and the eighths bar is here. So I need to draw a line going downwards just to make sure that we have got the same size. How many eighths do I need? I need 1, 2, 3, 4. So I need 4 eighths. Let's look at the next one. We have 2 fourths, that's it, 2 quarters. How many parts makes 2 quarters actually? Let's figure that out first. So we've got 1 quarter here and another quarter here. So I'm going to draw a line because we stop over there, okay? Now it says here that to make 2 quarters, you need 4 parts of something else. What do you need 4 parts of? Not a half, because that's only 1 part. So what's left? The eighths. And you can test it because look, 1, 2, 3, and 4. 4 of those make 2 of those. So that would be 4 eighths. Let's look at D. 2 eighths makes how many parts of 4? So let's draw up first 2 eighths, which is here. How many parts of 4 do we need? How many parts is that? Just the 1. So that's 1 quarter. Next one, we have something out of 8 has to equal 3 quarters. So I always look at the fraction that's first completed, which is 3 quarters, even though it's on the other side. I'm going to draw up my 3 quarters. That's 1 quarter, 2 quarters, and 3 quarters. So I'm going to stop there. How many parts out of 8 do I need? So look at my 8 bar, the one with the denominator of 8, and I'm going to count up how many parts I have in order to make the same sized bars. 1, 2, 3, 4, 5, and 6. So I need 6 out of 8 of those. Let's look at F. F says that 2 out of 2 is equal to, first of all, how many parts of 4? And then how many parts of 8? Now 2 out of 2 means this whole bar here. Okay, I'm going to try my best to draw it neatly, but no promises. Make sure at home you're using a ruler if you're doing this. So how many parts of 4 do I need to make that bar? I need 1, 2, 3, 4 parts of 4. So how many parts of 8 do I need? I need 1, 2, 3, 4, 5, 6, 7, 8. I need 8 parts of 8. Now let's have a go at labeling the fractions on the fraction wall. Off you go. Let's see what you come up with. So if I was to complete this fraction wall, I would do it as follows. I first see how many parts the bar is divided into, which is 1 part, 2 parts, 3 parts. So I'm just going to write that there. And then you just label each one as 1. So this is 1/3, this is 1 out of 3 of the parts, this is also 1 out of the 3, and this is also 1 out of the 3. Now try the next one for me. Have a look to see how many parts this is divided into. 1, 2, 3, 4, 5, and 6. So it's out of 6. So I'm just going to write that, because we know the denominator does not change, but luckily on a fraction wall, the numerator doesn't change either, because this is 1 out of 6, this is also 1 out of 6, and so are the rest. Last bar here, how many parts can you see this bar being divided into? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means this is a 9th, this is also a 9th, this is also a 9th, and you keep going as follows. So we have just created a lovely fraction wall. I wonder if you can create a neater one than mine. I'm positive that you can. Now, part B. Use the fraction rule to complete the equivalent fractions. So for example, 1/3 is equal to how many sixths? Have a little look, see? You have 1/3 here. How many sixths do you need to complete it? You need 2 sixths. So that means that how many, so you've got 1/3 here, 2 sixths here, and then how many ninths do you need? You need 3 ninths. So that's how you complete it. Next one, I'm going to look at the complete fraction first for this question, which is 6 ninths. So let's go to 6 ninths. 1, 2, 3, 4, 5, 6 ninths. Okay, I'm just going to draw a line to show us. You need 4 parts of what fraction? Have a look at the rest of your bar. Which bar has been split into 4 when you draw a line this way? Which one shows that the bar has been split into 4? This bar or this one? The answer is this one. So how many parts you need? You need 4 out of, look at the denominator, 6. So you need 4/6 of that. And then before that, you have to look at the 3. So look at the bar that has been split into 3. How many bars of 3 do you need to then make up 6 ninths? So look at the line, follow the line, follow the line. Right, stop. How many parts do you need of the third? You need 1 there and 1 there. 1/3 plus 1/3 is 2/3. Well done. Last one here. We have got our full number or our whole number, which is 1. And we need to see how many of these fractions or how many bars we need to make our number 1. Now, number 1 is a whole entire bar, if you can see there. So how many parts? It says you need 3 of what fraction? Here you can see the bar has been split into 3. So you need 3 out of 3 to make a bar of 1, because you need all 3 of those to make a bar that is the same size as 1. What about 6? When you look at the fraction out of 6, how many parts of that do you need to make the 1? You need all 6. You need all 6 parts. And for 9, you would need all 9 parts. Try this question. Are the statements always, sometimes, or never true? Circle your answer. So the first one says, and you can also draw a diagram if you want to support your answer. The greater the numerator, the greater the fraction. So the bigger the numerator, the bigger the fraction. What do you think? Part B, fractions equivalent to 1/2 have even numerators. So the numerator is always an even number. Is that always the case, sometimes the case, or never the case? And then lastly, if a fraction is equivalent to 1/2, so equal to 1/2, the denominator will be double the numerator. Is that always the case, sometimes the case, or never the case? Have a go at answering those for me. That is all for your maths lesson for today, Williams class. Enjoy. I hope you are enjoying learning all about fractions. It's a very nice new topic. I like it. Stay safe, and I'll see you really, really soon.